Well, hello everyone. This is KP the Math G here. We are looking at the 2014 free response question 1, and I have to admit that I studied this a little bit. Parts A and B are what we're going to do today. Those were really the easiest ones to do. I will tell you that when you get to part B, those of you who are taking the regular calculus class, you may have to do that problem by hand. And I could show you how to do that by hand if you request that, but by and large I'm going to do it basically by the calculator, just putting it into the calculator. I will suggest that if you have a calculator with either Y0 or Y1, whatever begins with whatever. Let's say you have Y1 right here, and you have that equals like that. You definitely need to put this A at T in there. You need to put this 6.687 times 0.931 raised to the T, or in this case, in your case, probably going to be an X there, which would be T for you. Put that in there. You are going to need it throughout this. I'm not sure about C and D parts, but you are going to need it for A and B for sure. I'm pretty sure you're going to need it for C. Yes, I would say that. And also for D. Yes, for all four parts. I was just looking at this just now. So yes, you're going to need it for all four parts. It just helps to have this available. And then when you get ready to integrate, say from 0 to 30, you do not have to waste time putting this back in every time. You can just put Y1, and then of course it will be dx, but then you can, if you have to do that, then you can put that in there right away. You can also you can call it up by that y bars. If you want to look at y, let's say this A at 30 or something, then you can just simply put 30 right in there just like that. Okay, and you can get the answer right away. Okay, that's the kind of thing that you need to be familiar with. Alright, so I mean, we could go on and on with this, but you need to have that in there already. I would just start out, if I had this problem here, I would go ahead and go to y equals, okay, y1 or y sub 0. Mine is in y sub 0, alright, but yours may be y sub 1. Okay, the first question says, find the average rate of change of A at T over the interval T between 0 and 30, including 0 and 30. Proper units are required, of course. Alright, so the average rate, and this again, average rate of change. This is, what is that? Average rate of change. Yeah, that's slope. So it's A at 30 minus A at 0 over 30 minus 0. That's how you do it. That is average rate of change. That will always work. Now, if you can find the derivative of this, then you can do it like this. Okay, 1 over 30, going from 0 to 30, but it's A prime at T dt. Alright, you would have to do it that way, and then that would be 1 over 30, and actually times A at 30 minus A at 0. And of course, that's the same thing. A at 30 minus A at 0 over 30 minus 0. But you got to understand, if you do it this way, it's got to be A prime at t, not A at t. Alright, so you have to remember to find the derivative of this and then plug that in like so. But it is A at 30 minus A at 0. And that's how that works there. Okay, so A at 30, again, you can plug that in. I just went ahead and did A at 30 minus A at 0. And in this case, what you're probably going to have is y1 at 30 minus y1, and then just put 0. And then you're just simply going to put 30 down here. 30 minus 0 is 30. And if you do that, you will find that your final answer is, and it will be a negative, so that's equal, well, let's see where we can put it, negative 1 point, no, it's point, not 1 point, no, sorry, negative 0.197. And since this is negative, what you can say is that the amount, has to do with grass clippings that's in a bin. They do decompose. Alright, so over a period of time. And so at this point here, this is the average. Okay, so you can say that and we're still dealing with amount. The amount of grass clippings is, alright, negative is decreasing, so decreasing at a rate, let's see, at a rate, yes, it is a rate, because that's a rate right here. That's what you're finding. It is a rate of, now do not say negative here, 0.197, and of course this is in, let's see, pounds per day. So let me erase this for the time being. Alright, this would be pounds per day. Alright. Yes, pounds per day. Yes. And that is the average rate of change. Alright, that's what it's asking for. Yes, find the average rate of change. Okay. Alright. And you can do either that, or you can say like that, save you some time there. Alright, it is definitely a rate. I'm just going to put 30 down here somewhere. Alright, 30 minus 0. Okay, there it is right there. And that's what you have to do right there. Okay, and that's the A part. Average rate of change. A of the largest minus A of the smaller number divided by the larger minus the smaller. Okay, that's average rate of any change. You'll always do that. Okay. All right, B part is on the other side. I may have to flip back to this here as well. So find A prime at 15. Interpret the meaning. This is the instant t is equal to 15. Alright, days. In this case, it's days. Alright, the moment that it gets to the 15th day. Alright, so what is it here? We're finding A at 15. So remember, A at T is equal to 6.687 times 0.931, I think it is, and that is raised to the T. Again, if you want to find A at T, I can show you how to do that. It would take some time to do that. If you don't know the antiderivative of this, just telling you I mean, if you can memorize it, it is equal to simply A at T, which is 6.687 times 0.931 to the T. So it's all of A at T times now ln of 0.931. ln of what's underneath here. Okay. All right. And that's what you can do. Plug in the 15 right there. If you can memorize that, you've got it made. That is it right there. It's simply A at T times ln of whatever this is that's holding up the exponent T here. Okay? All right, the base. All right, ln of the base. I had to think of that word there. Or you could just simply say, you can simply go in, and again, if you already have that in your y1, I got it in y 0, but if you got y1 is, I'm just going to just say A at T. Alright, then what you can do is you can do that, I think it's, you know, so let me look at my calculator right here. It would be D, and in this case we are dealing with X, but we know that X is really T, and then of course Y sub 1, like that. And then of course it will have at the bottom X, in this case, equals 15. Alright, it'll look like that, and that would be so much easier to do. Of course, mine is Y sub 0, but we're going to say it's Y sub 1, and then you come up with your answer. Either way, you can put 15 right here as your exponent right there, and either way you should be able to come up with the same answer, and that is yeah, negative 0.16359, like that. Okay. And of course here, the amount of grass clippings in the bin is decreasing at a rate. Okay. Decreasing at a rate. The amount of grass clippings, right, is decreasing at a rate of, in this case, now again, no, it's already decreasing is the negative sign. That already is associated with the negative, so you don't have to put the negative here. Alright. And again, that is pounds per day. Alright, and there it is. I think on the first one, all you had to do, you didn't have to explain anything. You just had to just get the correct unit. So on the first one here, we did not have to, I just looked at that. You just really need to put the correct units there. Okay, and sorry about that. I was looking at B while I was looking at A, and you don't have to have all of that. You can just put down right here, I'm sorry, pounds per day. Alright, they're going to make that as simple as possible. Alright, and this, you can leave the negative, you don't have to explain that. You know, it is a negative answer there, so you can just leave it like that, okay? Alright, and that's really, if you show this and come up with this answer here, and the units, I think it's just going to be, it's just only 1 point, answer with units. Alright, B part is the answer with the interpretation. Let me just emphasize this on the B part right here. You know, we could go ahead and figure out what this here is, how to find this derivative if you wanted to. I mean, it does take a little bit of time. So, I mean, I could show you. Those of you who are in the regular calculus, you might want to see this. So, since I do have a little time left, I may just go ahead and show you. So let's just, instead of A at T, let's let, and I'm going to do the substitution in just a little bit. Y is equal to a, let's say, I'm trying to think, AB to the X, and that's what we got, A, B, in this case to the T. Alright, so I'm going to put it as X right now. So really, if we want to, we can go ahead, and I want to eventually solve for X, so I'm going to do that. We'll divide by A, So Y over A is equal to B to the X. Okay, now A and B are constants, okay? Y and X are variables. Keep that in mind. Alright, so if we want to get X by itself, we can do ln on both sides. Ln Y over A is equal to ln B to the X. Okay, and of course, I like to just divide this up. This is ln, remember there's a ln of A over B is ln of A minus ln of B. Alright, ln of Y over A is ln of Y minus ln of, and of course I can put this in front, X ln of B. If I were to take the derivative of both sides, okay, derivative of ln of Y is actually 1 over Y, but it is d, you know, so dy over dx, like that. Alright, and the derivative of ln of A is 0. Alright, and the derivative of x is 1, and of course it's just 1 ln of B. 1 times ln of B. Alright, this is just ln of B. Okay. Okay, I don't need the 1 here. Alright, and I'm just going to solve for dy over dx, so I'm going to multiply by y, both sides. Alright, dy over dx is equal to y ln of b. But now y is ab to the x. So if we say that y, and we substitute these in there, y is equal to 6.687 times 0.931 to the t, or yeah, to the t. We can substitute that back in here. So dy over dx is equal to And I'm just like, A is this and B is this, see. A is 6.687 and B is 0.931. I'm just substituting that back in here. And instead of X, I'm using T, back where I was. So this is all of A at T, so which is equal to 6.687. This is all of Y now, okay, times 0.931931 to the T times ln of B, which is, well, I need to scoot this over, so 6.687 times 0.931 to the T, alright, times ln of B. Now B is 0.931. Okay, and if you plug 15 in that one, you will get the exact same answer. Okay, that took a little bit to do that, but needless to say, that's how I would. I mean, if I didn't know how to do that, I could do that. But then again, just to show you, I could just plug that. I mean, do it from the calculator itself, like I just did a while ago. Okay, I erased everything here, but it would that other way is just so much better. All right, that's all I'm going to do, because C is going to be a little bit long, and so is D, and I might just want to do C by itself and then part D by itself. So anyway, yeah, it would just take too long to try to do everything. So I'm just going to do C and D. Listen, I mean, I still study this. I've got books, I've got videos that I look at, and I study that. I really do. And I know some of you who are taking the AP class. I mean, you've already taken this AP class. Some of you may have already graduated. Still got to take this on the 13th. Do your best on this thing. Give your all. You've given your all in this class. You've got your grade already. Do your best on this test. Okay. And then those of you who are taking calculus, just keep on. If you haven't taken your final exam, this would be good preparation. That's why I showed this. I just want to prepare. You know, I give lessons for both the AP classes and the calculus. Those who are taking the calculus, take this seriously. Okay, take this seriously. I mean, I take a lot of time to study this. Your instructors or take their time to study this. We always study. We always, and there's no end to it. You just, in your field, whatever you get into, you're going to have to sacrifice a lot of things to learn, and just sit down and learn what you're wanting to accomplish in your life. Make the best of it. Okay, that's KP the Math G. You can subscribe if you haven't done so already. Subscribe. You can make a comment if you'd like to, and if you'd like to, go ahead and hit that like button. Even though, yes, if you don't like the Dallas Cowboys, well, okay, you still hit the like button based on what I did up here, right? And if you don't do any of that, you know, I'm okay with it, because this is for you and not for my glory. I always say that. Anyway, ladies and gentlemen, this is KP the Math G signing off. Have a great, great day.